Assalamu alaikum. I am presenting on the topic of hazard assessment of earthquake based on Bayesian network model, which was a final year project for BS Civil Engineering and was supervised by Dr. Asan Maksoon. These are our group members: Abdul Mutal Saeed, Ali Hasan Chima, Talal Amjad and Mutibur Rahman, who worked on this project for about a year. The summary of this project includes a brief overview, the objectives, the methodology we used, the tools and technologies we applied, the benefits of the project, and at the end we will discuss the final deliverables and the conclusion. Project overview. By definition, Bayesian networks are increasingly popular method of modeling uncertain and complex domains such as ecosystem and environmental management. At best, they provide a robust and mathematically coherent framework for the analysis of this kind of problems. Scope of work. Bayesian networks, despite being a popular and effective method for statistical analysis in the field of environmental management, has never been used in Pakistan to address the hazard assessments specifically. This model may prove very helpful for the policymakers and researchers to develop sustainable and efficient policies for land use, disaster management, town planning, road mapping, and other environmental issues. The study area includes a patch of Karakoram Highway from Gilgit to Khanjarab Pass, which covers a distance of 274.4 square kilometers in between longitudes and latitudes of 35.8819 north, 274.4643 east, and 36.8539 north to 75.4589 degree east. Following are the points which were covered in our project. First was the realization of the importance of the earthquake hazard analysis, then Bayesian modeling for hazard assessment, which included the extraction of input data, model building, then use of satellite for model building, which included the extraction of attribute values. Then we trained the Bayesian model and then used it for the hazard assessment of earthquake disaster. There were four main objectives of our project. First was the earthquake hazard data, second was Bayesian model development, third was increasing the overall accuracy of the model, and the fourth was earthquake hazard assessment of Karakoram Highway from Gilgit to Khanjarab Pass. Methodology. This flow chart represents the overall methodology of the project, which includes three steps. In first step was data acquisition, in which we collected data and extracted the attribute values through ArcGIS. Second step was model evaluation, which included Bayesian network model and hazard assessment model. Then we checked its validation through ROC and SEA. These are the datasets, input datasets, which were used for the hazard assessment modeling, which were land cover, rock type, soil type, aspect, distance to river, rainfall, moisture, vegetation, slope, road density, elevation. These are all the datasets which we use for the hazard assessment modeling. Tools and techniques. These are the tools and techniques which we used in our project. First was the Landsat 8 satellite data. Second was ArcGIS software and the Python libraries. The benefit for this project includes town planning, road mapping, disaster management. It is very helpful in all these three fields. Final deliverables of the project. The final output of the project was Bayesian network model itself, the maps and statistical results. Bayesian network model performance. Through Bayesian network model performance, we have assessed three hazards: debris flow, collapse, and landslides. The scoring model represents the adequate accuracy of the model from logarithmic loss, quadratic loss, spherical payoff, and area under the curve from the scale of 0 to 1. These same scoring models are validated for all hazards, which includes collapse, You can see the table here, and landslides as mentioned here. Maps. In these images we can clearly see the visual representation of the probability of debris flow, collapse and landslide in figure A, B and C respectively, which are from 0 to 1. 0 is the lowest and 1 is the highest. This is a probability. In figure D, E and F, this shows the visual representation of hazard and intensity of debris flow, collapse and landslide respectively. This figure combines all the maps presented above and visually represents the hazard change zoning maps of Karakram Highway. Statistical results. The following graph represents the accuracy of the model through area under ROC curve, and for it the model evaluation of value of ROC curve must be between 0.5 to 1 or 50% to 100. From the visual inspection of the results, it seems that ROC forms a trapezoidal curve indicating an increase in the hazard disasters in the high hazard area. In the figure, AUC is 0.88 or 88%, representing a disaster chain hazard model accuracy which is significantly high. The hazard chain densities. The following table shows the percentages of area seeded and their ratio for 5 different hazard classes. Conclusion. The seismic earthquake disaster chain hazard model is presented in which hazard intensity and chain probability are determined by Bayesian network model. ArcGIS produce earthquake disaster chain maps. The exceptionally high hazard zones are mainly concentrated inside the 8 km radius and focus on Gilgit and Atabad regions. The high hazard zones are located in southwestern regions of the research area. The regions with medium danger levels are strewn across the entire study area. The northern and eastern parts of examined area mainly exhibit extremely low to low hazard values. Thank you.